All right. So with that, I'd like to ask you this. Calculate the mole of theoretical air required for the complete combustion of 100 moles of fuel containing 50% by mole of C2H6, 40% by mole of H2, 10% by mole of nitrogen. So in here, let's write our basis. The basis would be 100 moles of fuel. So for the 100 moles of fuel, fuel consists of C2H6, H2, and N2. So that's creator table lang. Mole, this is 50, this is 40, this is 10. So let's write the C, H, S, O2. So this one, the first one would be 2 times 50, it's 100. 6 times 50 is 300. There's nothing, there's nothing. For H2, there's no C. 40 times 2 is 80. Blank. And then N2, there's nothing in here. So walang problem. Let's look at the total. The total would be 100. This is 100. This is 380. This is 0. This is 0. Guys, again, what's the formula for theoretical oxygen? So that's the moles of carbon plus moles of sulfur plus 1/4 of the moles of hydrogen minus the number of moles of O2. Very good. So in here, let's just use that. 100 plus 0 plus 1/4 of the 380 minus 0. So that's 195 moles of O2 yung theoretical oxygen natin. So what's being asked is not the theoretical moles of oxygen, but the theoretical air. So in order to solve for theoretical air, it's basically TiO2, and then you know that 21% out of the 100% air is just oxygen. So guys, 195 times 100 divided by 21, how much is that? 928.57 moles of air have to be supplied. All right.